Hello everyone. Today we are going to discuss different rearrangements. There are the different types of rearrangements are there in which there is the migration of different groups are there. Today we are going to discuss the rearrangement in which the electron deficient nitrogen has been migrated any electron rich site. In every chemical reaction generally there is always the flow of electron from electron rich site to deficient site. In these reactions also we are going to find out we are going to do perform the same route, that is the flow of electron from electron rich side to deficient side. There are the different types of reactions in which electron deficient nitrogen atom is generated by the loss of leaving group, and there are the different types of reactions are there. For example, there are the different reactions in which first is the Beckman rearrangement. Beckman rearrangement. So today, first of all, we are going to understand what is meant by Beckman rearrangement. Generally, it is a reaction of oxide. This reaction is carried out in an acidic condition. It is the reaction of oxide. It is carried out in acidic condition. Acidic condition. That means we have to use the different Lewis acids for the progression of the reaction, and by the treatment of different Lewis acid on oxide, we are getting the substituted amide as a product. And there are the different synthetic applications of these Beckman rearrangements, and that's why we have taken these rearrangements into our consideration. Now, in these acidic conditions, there are different acidic reagents. They are used in this reaction as like PCl3, PCl5, POCl3, then polyphosphoric acid, that is PPA, then sulfuric acid, H2SO4, then SOCl2, and so on. These, by the presence of these acidic reagents, we can able to carry out these reactions very successively. So we are going to take the example. First of all, the basic reaction in this, it is the reaction of oxide and generally takes place in the presence of and in an acidic condition. Now we are just taking the reaction. In this reaction, we are generally use the oxide in acidic condition, H like H plus. These acidic reagents I have already told to you. These oxide is reacted in acidic condition. There is the formation of a substituted amide. And it is the product of this reaction. Mechanism. In Beckman rearrangement, the mechanism is carried out in two steps. In first step, synthesis of oxide. In the first step, we have to synthesize the oxide. Generally, we are using for synthesis of oxide, we are using either ketone or any aldehydic family. Aldehyde or ketone, carbonic compound we are using for the synthesis of oxide. So, I have taken the general reaction of it, R, C, double bond O, R as a parental molecule, and by doing the reaction with NH2OH, I am getting oxide. R, C, R, double bond N, OH. It is oxide. So first of all, we are going to determine the mechanism of it. Generally, in every reaction is in which there is always the flow of electron from electron rich side to deficient side. So generally, this carbonyl carbon is considered as an electron deficient site, and there is a lone pair of nitrogen present, so obviously it is an electron rich site, and always there is a flow of electron from rich side to deficient side. So we are going to do the mechanical flow of electron from rich side, that is from nitrogen to the carbonyl carbon, and the electron density will move toward the oxygen. Because of that extra electron density, it will get the negative charge. and the mechanism will become in which R C R O minus N H H and OH. Now it will get a positive charge because nitrogen has valency 3 and now it is getting a 4. So it is getting a electropositive charge. So the negative charge can extract the proton and stabilize the positive charge of nitrogen. And then what happens? In the next step, we are getting R, C, R, OH is here, N, H and OH. In most of the organic reactions, generally what we can do, whenever there is a near to heteroatom, whenever there is a formation of OH, generally there is the elimination of water takes place. And this step we have to remember forever. Now we have to eliminate the water from it. How we can eliminate? That will come here and that which will be eliminated out. Generally we are using the acidic conditions here. That means H plus already we are using. If we are using the H plus before that, then we can also convert this OH into OH2 plus. Either you can convert it to OH2 plus or you can put it as a OH, whatever it is, right? So that we are getting this product R, C, R, double bond N, OH. That is oxide. Okay, so this is the synthesis of oxide. Now we are going to discuss the step number 2. In a step 2, we have taken this oxide. Step 2, we have taken this oxide as a reactant R, C, R, double bond N, OH. It is a oxide. And this oxide is treated with the acidic reagent like a H plus. Either it is a polyphosphoric acid, either it is a any type of acid like a PCl3, PCl5, SOCl2, whatever it may be, or H2SO also. So we are taking the H plus. So what happens? I already taught you the important concept. Whenever OH is ever, it has a very important property, hydrophilic property it is. That's why it has, this oxygen has the affinity of H plus and it will directly extract the acidic proton. So what happens? R, C, R, double bond N, OH2 plus. Now these OH2 can be eliminated very easily. It has a driving force in it because it has already the electropositive character. So what we can do, there is a certain rearrangement and our topic name is also there. It is a Beckman rearrangement. The rearrangement it indicates there is the migration of one group from one place to another place. And analogous to that, we are going to do the rearrangement of that. The anti-group, this Beckman rearrangement is a stereospecific rearrangement in which generally there is the migration of the group which is always anti to the NOH. That group is always migrated. That means anti to OH group is always migrated from carbon to nitrogen. That we have to remember. Okay. So in that sense, that R group will be migrated here and there is a elimination of OH2 plus. So minus OH2, what happens? R, C, double bond N, R. So positive charge will be here. But what is eliminated out? Eliminate out OH2. Again that is present in C2. That is present in that same reaction RB reacting plus. So that again that OH2 will do that type by this way. So what happens? We are getting product R, C, OH plus charge will be here and nitrogen R. Now this is electropositive species now. So we can minus eliminated minus H plus from here. So what we are getting R, C, OH double bond N R. So we can able to tautomerize it into it is in a enol form. So we can convert it into keto form also because double bond is here and analogous to that OH is here. That's why it is enol form. So we can convert into a keto form. So that will be here in this way. So what we are getting? R C double bond NHR. That is substituted amide. In this way, we are easily prepare the substituted amide reaction in a amide. Okay. Now we are going to find out the different applications of it. Different applications of it. So there is a very important application of Beckman rearrangement. It is a inner synthesis of caprolactam followed by the conversion it into the polymer. That is, it is converted into nylon 60 or polymeric compounds. And these nylon is used in a different as a very important compound in different polymeric reactions. There is a very important applications of Beckman rearrangement. Okay, so in this way we are learning today the important reaction Beckman rearrangement. In the next the next version, definitely I am coming along with different types of reactions with you. Thank you.